Welcome, everyone. Thank you so much for joining us. I'm Christine Cunningham, Professor of Practice in Education and Engineering at the Pennsylvania State University and a member of the National Assessment Governing Board. I'm also your host for today. The National Assessment Governing Board oversees the National Assessment of Educational Progress, or NAEP, which is also known as the Nation's Report Card. Today, we'll be talking about the 2019 Nation's Report Card results for science in grades 4, 8, and 12. Then we'll discuss what these results mean for science education. Before we begin, a few housekeeping notes. All attendees have their microphones muted. Please type your questions into the box labeled Q&A at the bottom of your screen. Be sure to join the conversation on Twitter. We are using the hashtag NAPEScience and encourage you to follow the governing board at GovBoard. If you miss a moment, this event is being recorded and will be shared on the governing board website soon. Now, let's start with a welcome from Governor Haley Barbour, Chair of the National Assessment Governing Board.
Hello and welcome to you all. I'm Haley Barbour, Chair of the National Assessment Governing Board and former Governor of Mississippi. This last year, the entire world has been focused on science and science learning. How do we prevent the spread of a vicious virus? How do we develop new vaccines? Beyond our own planet, how did that helicopter fly on Mars? What does a black hole look like up close? Scientific progress never stops and never stops inspiring all. Findings from the Nape Science Assessment help us understand what our nation's students are learning in life sciences, earth and space sciences, and physical sciences. We also learn valuable lessons on students' course taking, their interest in science, what science activities they like, what scientific tools they use, and so on. We appreciate your time today as we delve into what NAEP can teach us about students' scientific knowledge and skills.
Thank you, Governor Barbour. To preview today's agenda, we'll turn next to Lynn Woodworth, Commissioner of the National Center for Educational Statistics, or NCES. He will introduce the science assessment, and Peggy Carr, the Associate Commissioner for Assessment at NCES. Peggy and Lynn will then take audience questions. After we learn about the results, former governing board member Carrie Schneider and I will answer questions from key stakeholders in the science education field. But first, before we hear all the data, I want to share a video with you that shows what the NAEP Science Assessment measures. Science can be both extraordinary and ordinary, everywhere, every day. Science education enables students to understand the world around them. I'm Christine Cunningham. I work in science and engineering education. I've learned from my work that our world needs scientifically literate people. People who understand key facts, concepts, principles, laws, and theories of science, because scientific knowledge helps us solve real-world problems every day. Scientific knowledge and understanding have been crucial during this pandemic. Whether you are an average citizen trying to understand mask-wearing guidance, or a scientist racing to create a successful vaccine. The National Assessment of Educational Progress, also known as NAEP, or the Nation's Report Card, measures students' scientific knowledge and skills. NAEP Science assesses 3 content areas: physical science, life science, and earth and space sciences. Let's take a closer look at each. Physical science principles, including fundamental ideas about matter, energy, and motion, are powerful concepts for making sense of our world. Matter, the stuff that makes up everything around us, is important for kids to understand. And knowing the characteristics of familiar forms of energy and motion leads to an understanding that, for the most part, the physical phenomenon they observe can be explained. Life science principles are essential for understanding how living organisms function and interact with their environment. Life science is also crucial for understanding advances in science and technology. We regularly ask questions related to health and disease, such as what constitutes a healthy lifestyle, and how can we deal with changing bacteria, viruses, and parasites that thwart efforts to develop antibiotics and vaccines. Life science provides the tools for understanding and addressing these questions. From the International Space Station to the Mars Perseverance rover, the past few decades have brought rapid changes in Earth and space sciences. The study of Earth has shifted from surface geology and mining toward Earth systems and global climate change. Students need to understand how innovative technologies open new ways to monitor and measure the Earth's physical geography, as well as learn more about our solar system and our place in the universe. As the world around us changes, it remains critically important to continue educating and inspiring our children about physical, life, and Earth and space sciences. It's also crucial to assess their progress so that we may guide them to an even brighter future. Learn more about how Nape assesses students' scientific knowledge and skills at nationsreportcard.gov. Now I'm delighted to welcome NCES Commissioner Lynn Woodworth to the virtual stage. Lynn?
Thank you, Christine. I'm Dr. Lynn Woodworth, the Commissioner at the National Center for Education and Statistics. I'm here to open the official statistical release of the National Assessment Educational Progress 2019 Science Assessment Results. The NAEP Science Assessment results are for 4th grade, 8th grade, and 12th grade, and are national level representative results for the country. They will be presented to you today by the Associate Commissioner for Assessment at the National Center for Education and Statistics, Dr. Peggy Carr.
Thank you, Commissioner. I am the Associate Commissioner, as you just shared, for all the assessments in the National Center for Education Statistics. And it is my pleasure to present to you today the results from the science assessments for grade 4, 8, and 12. These results are interesting, and not only because they are the third in a series of data collections for this science framework, but also because they represent the last of the major data collections in 2019 prior to COVID. As you recall, we have already released the 2019 reading and math results. So let's get started. As a reminder, we collected these data between January and March of 2019. The sample for science was national only at all 3 grades. And you can see the school and student sample sizes here. Additionally, this was the first administration of science on tablet computers. So let's begin with defining what is NAEP science. That wonderful video from the National Assessment Governing Board did a great job in describing the content area, so I won't have to spend too much time here. The science assessment measured students' familiarity with the natural world, including their knowledge of scientific concepts, their understanding of scientific principles, laws, and theories, and their ability to engage in scientific inquiry. As outlined in the science framework, there are 3 content areas for NAEP science: physical science, life science, and earth and space science. I will share results for these 3 content areas later in the presentation so we can see how students perform, not just overall, but within these 3 content areas. The framework also identifies 4 science practices. They cut across each content area. They include identifying science principles, using science principles, using scientific inquiry, and using technological design. Before I share the results, I wanted to highlight a unique aspect of the science assessment, and that is our scenario-based tasks. also known as SBTs. Although our assessment is fully digital now and includes interactive discrete questions, SBTs are a bit different. Part of the assessment since 2009, these scenario-based tasks engage students in computer-simulated scenarios, allowing them to demonstrate skills of scientific inquiry that discrete and short response items may not always capture. There are two types of tasks: interactive computer tasks, which allow students to conduct investigations in a computer-simulated environment, and hybrid hands-on tasks. These tasks involve NCES-provided science kits, which allow students to conduct investigations using materials provided. Students then record the results on a tablet computer. We have released 3 of these tasks, 1 at each grade. They include How Seas Travel at grade 4, Clear Water at grade 8, and Bicycle Materials at grade 12. How Seas Travel is a 30-minute hybrid hands-on task in life science. It measures students' understanding that organisms have certain characteristics that help them survive and reproduce. In the scenario, students are planting a vegetable garden and notice that dandelions are also growing in the garden. The question is, how did they get there? The students are provided actual seeds and are asked to predict whether they spread by wind or by animals. A fun task. The Clear Water task is a 30-minute interactive computer task in the Earth and Space Sciences content area. This task asks how human activities can alter Earth's systems, such as land and waterways. Students engage in scientific inquiry to investigate the cause of cloudiness in a river that flows into a lake used for fishing and recreation. Bicycle Materials is a 15-minute interactive computer task in physical science. It assesses 12th graders' knowledge about the properties of matter and changes in matter. The task assesses students' understanding of how chemical elements, like metals, are grouped in the periodic table based on similar characteristics. They are asked to analyze the atomic structure and physical properties, density and hardness, of 3 different metals to determine the best material to use to construct a lightweight and strong bicycle frame. I will begin with an overview of all 3 grades compared to the previous assessment in 2015. Here you see the top line has average scale scores and indicates whether the score is different from the 2015 assessment. Grades 4, 8, and 12 are represented in the columns. In 2019, grade 4 students showed a 2-point decline, indicated by the downward pointing arrow. Performance at grade 8 and 12 did not change from 2015, as indicated by the gray diamonds. Next, we'll take a look at performance by percentiles. At grade 4, higher performers, those at the 75th and 90th percentiles, did not show any change from 2015. But middle performers, those at the 50th, and lower performers, those at the 25th and the 10th percentiles, declined. At grade 8, you also see the lowest performers declining, while grade 12 has no change. The decline that we're seeing amongst the lower performing students, particularly the 25th and the 10th percentiles, is concerning because this is a pattern we've seen before in other subjects. Finally, let's look at the content areas: life science and earth and space sciences. At grade 4, student performance there declined compared to 2015, but no changes at either grade 8 or 12. Now that we have the overview picture, let's take a closer look at each grade, beginning with grade 4. Here you see the grade 4 science results for the first year, 2009, and the previous year, 2015, and the most recent year, 2019. An asterisk indicates a statistically significant difference from 2019. As we saw a moment ago, 4th grade performance has declined from 2015. However, scores are up by about a point from 2009, as indicated again by the asterisk. Results by race ethnicity show that white and Black students' performance declined compared to 2015. However, all racial ethnic groups, except whites, have shown improvement since 2009. This improvement has resulted in the narrowing of the white-Black, white-Hispanic, white American Indian Alaskan Native, and the white 2 or more races achievement gaps. The white Asian Pacific Islander scores are not statistically different from each other. The gender story is also interesting. While both boys and girls did show a decline from 2015, girls are still performing better than they did a decade ago. Boys are not. Turning to our percentiles, you see from 2009, higher performers have improved, while others have remained flat. And like we pointed out a moment ago, middle and lower performing students have shown declines compared to the previous assessment. The content story is a mixed bag. From 2015, performance in life science and earth and space sciences has declined 4 points and 2 points, respectively. The life science declines were experienced across the distribution, with all percentiles declining except the highest performers. In all 3 content areas, the students at the 10th, 25th have declined compared to 2015. However, compared to 2009, overall scores for physical science and earth and space sciences have improved along with the performance of higher and middle performers. In earth and space sciences, those at the 25th percentile improved. There was no change overall in life science, and scores for the lowest performers declined. The achievement level findings mirror the percentile findings. That is, the bottom of the distribution grew compared to 2015, and the top of the distribution grew compared to 2009. 27% of the 4th graders performed below Nape Basic in 2019, which was greater than the 2015 data point. 36% of 4th graders performed at or above Nape Proficient. This percentage is lower than the previous assessment, but higher than the 34% in 2009. That completes the grade 4 overview. Now let's look at the grade 8 results. Again, asterisks indicate statistical significance from 2019. No changes were observed overall from 2015, but there was improvement from both 2009 and 2011. I should also note that there is a score for grade 8 in 2011, while there isn't one for grades 4 and 12. That is because NCES did a very interesting study aligning Nape with the Trends in International Mathematics and Science Study, also known as TIMSS. We have projected scores for all states, grade 8, on the TIMSS assessment, a very interesting study. For race ethnicity, we see no change from 2015, but all groups have increased their scores. And like grade 4, the white Black, white Hispanic, white American Indian, Alaskan Native, and white 2 or more races gaps narrowed. Performance between white and Asian Pacific Islanders is not statistically different. Looking at results by gender, there is improvement for both boys and girls. While in 2009, performance between 8th grade boys and girls was different, the gap has been closed. 8th grade girls and boys in science are no different from each other. This is a finding I just reported for grade 4. So it's really encouraging to see girls closing the gender gap, especially with the emphasis on STEM. When we examine the percentile story, we see improvement from 2009 across the distribution. Higher, middle, and lower performers all showed improvement. However, from 2015, the lowest performing students have lost ground. The content areas show no change in the overall scores from 2015. But we do see the scores of the lowest performers declining across all 3 content areas, while the scores of the higher performers have improved in both physical science and life science. From 2009, overall scores have improved in 2 of the 3 content areas. That improvement has been mirrored with increased scores among students from the 25th to the 90th percentiles in physical science and life science. The achievement levels show that a third of 8th graders are performing below Nape Basic, and 35% are performing at or above Nape Proficient. Both numbers are unchanged since 2015, but have improved since 2009. Finally, let's take a look at grade 12 results. There are no asterisks in the grade 12 results, indicating no change in the average score. It remains at 150. The percentiles largely show the same pattern, except for the 10th percentile. There we see a decline amongst the lowest performers since 2009. Not shown here, but worth mentioning, is that there were no performance changes for either race, ethnicity, or gender since 2009 or 2015. However, there is still a performance gap between 12th grade boys and girls. Recall that that was not the case in either 4th or 8th grades. There is no change in the content areas overall compared to both 2015 and 2009. The percentiles do show a little movement. Notably, both physical science and life science declined at the 10th percentile compared to both 2009 and 2015. The achievement level findings show 41% of 12th graders performed below Nape Basic in science, and 22% performed at or above Nape Proficient. As part of the Nape data collection, we asked students, teachers, and staff about their educational environment. We've highlighted a couple of findings here, but please visit the report card, the nation's report card, for even more insight. I do want to emphasize, though, that these next few slides have correlational data and therefore should not be used to establish a cause and effect relationship. This is because there are many factors that may influence student achievement. We asked fourth grade teachers and eighth grade students how often they engage in various scientific inquiry tasks. 30% of grade 4 students have teachers that say they never, to once or twice a year, engage in scientific inquiry. 42% of grade 8 students say they never, to once in a while, engage in scientific inquiry. These results suggest that the more frequently a student engages in scientific inquiry, the higher their NAEP scores. But of course, it could be the opposite. We also asked 12th graders about their course taking. In 2019, 41% reported having taken biology, chemistry, and physics. 37% reported taking biology and chemistry, and 22% reported taking biology and another science class. To see how course taking may correlate with performance, we can examine findings by percentiles. Students at or above the 75th percentile, represented by the medium blue, are more likely to have taken the 3 science courses compared to those below the 25th percentile in the lighter blue. On the other extreme, lower performers are more likely to have only taken biology or another course compared to the higher performers. This suggests a clear relationship, although again correlational, between course taking and performance on NAEP science. We observed similar course taking patterns among the race ethnicity groups, except for Asian students. Almost 60% of these students reported taking all 3 science courses, significantly higher than any other racial ethnic group. Similarly, males reported taking all 3 science courses at a higher rate than their female counterparts. It will be interesting to see how these data from the high school transcript study can help contextualize these findings. This data can help us examine differences in who is offered all 3 science courses and differences by school, location, region, etc. So let's keep a lookout for this study. It's coming up soon, later this year. Before we transition to questions, let's quickly summarize our results. Compared to 2015, grade 4 scores are lower, while grade 8 and 12 scores are unchanged. Compared to a decade ago, student performance in grades 4 and 8 improved, while performance at grade 12 did not change. Scores declined for students at the 10th percentile compared to 2015 overall, and across all content areas in both grades 4 and 8. 27% of students at grade 4, 33% at grade 8, and 41% at grade 12 did not reach the NAEP basic achievement level. And 41% of 12th graders reported taking biology, chemistry, and physics. So we thought it might be interesting to take a look at patterns in the percentile findings across all 3 subjects. By that I mean science, reading, and mathematics over the past 10 years. Divergence, when higher performers are holding steady or improving, while lower performers are holding steady or declining, really has been a theme of the releases this decade. Here we will examine the pattern more closely. Let us begin with grade 4. You will notice the columns represent science, reading, and mathematics. And we're comparing data over the decades, so from 2009. In grade 4, you'll notice that higher performing students have improved over the decades across all 3 subjects, while lower performing students have either showed no change or declined. In grade 8, you see that science is bucking the trend and that all percentiles have improved over the decade, resulting in overall improvement. However, in math and reading, higher performers are improving, while lower performers are declining. The no change from a decade ago is a result of these groups pulling apart from each other. Finally, we see for grade 12, the lowest performing students have declined from 2009 in all 3 subjects, while the top is flat. The overall score for math and reading is being pulled down by lower performers losing ground. These results can be found online at nationsreportcard.gov. You can also explore the scenario-based tasks on this site. Follow NAEP on Facebook at the National Assessment of Educational Progress and on Twitter at Nape_NCES. In conclusion, as always, I would like to offer our sincere thanks to the students, teachers, and schools who participated in the 2019 NAEP Science Assessment.
Thank you so much, Peggy. I'm Laura Logerfo, Assistant Director for Reporting and Analysis at the National Assessment Governing Board. We'll now turn to questions that have popped up in the Q&A box. We have a few for Peggy and I think a couple for Lynn. The first question I'm going to go to is to Peggy. And the question is, I'm trying to find it amidst all the questions that are popping up so quickly. The question is, I'll go with this one actually first. Are the 2009, 2015, and 2019 the only years the assessment was administered?
Yes, for 4 and 12, that is the case. But for grade 8, we did administer the assessment in 2011. We did that linking study, that really interesting linking study with TIMS, and did a projection for all of the states and the District of Columbia and so forth. But other than that one data point, yes.
All right, thank you. Here's another question. If we are using scenario-based tasks for the first time, how can we compare earlier years with 2019 if the instrument is different?
Well, the instrument isn't really different. We've been using hands-on tasks for quite a while. We've gotten better at it since the earlier years. And I think the measurement, our improvement in the measurement and what they tell us about what students know and can do has also improved, but we're not new at scenario-based tasks by any means.
Okay, thank you. This one is going to be for, I think, Lynn. Do you anticipate a significant decrease in the scores or the achievement levels following the pandemic? And if so, what should we do about that? You maybe answer the first part.
Right. So, of course, we don't have any way to know yet what the actual scores are going to be post-COVID. It's reasonable to believe, I was a teacher for 11 years. I think anyone who's been a teacher will tell you it's reasonable to believe that the impact of COVID will likely have a negative effect on achievement for students. We do have the next NAEP assessments coming up in 2022. We were supposed to have done them this spring in 21. We had to delay them because there just weren't enough kids physically in schools for us to be able to get the results. So we should have a good idea very soon what the results are going to be and what the impacts will be as far as how much impact did occur because of COVID. And then as far as how to address those, well, we kind of have to see where we are. And then once we see what the impacts are, then we can start looking at ways to address the changes and address the differences.
Good points. We have a couple of people have asked, how does the science measured by Nape differ from the next generation science standards? So kind of how those kind of play out. Several questions about that.
Let me say, Laura, that we're lucky because I think in the next segment, we'll have Dr. Snyder, Garrett Snyder, who knows this more than I think any of the rest of us, because he worked on both the next generation science standards and the NAEP and also the TAIL. So he's our expert. So we'll leave him to answer the more substantive part of that question. But let me say, we did do an alignment study. The National Center did an alignment study with the next generation science standards and our two science related assessments, both the science and TAIL. And there is a moderate alignment between the content, but not totally. I would say moderate to low to moderate in most cases, but the details differ. And we're going to let Kara tell us about that.
We'll hold it in the pocket. Okay. We have, this one is about some of the data that we saw. Are the declines at the bottom and the increases at the top seen across different race and ethnicity and free and reduced price lunch eligibility groups?
Well, Lynn and I, we got a lot to say about this one, don't we, Lynn?
I think there might be a
first?
slide.
We knew that this was going to be a question. We knew this was going to come up because it's a question we had as well. And so it's something that we definitely dug into. You can see this from the slide here that when we've looked at it, that in fact, we do see that this occurs both within students who are low SES, those who are eligible for National School Lunch Program, and higher SES, those who are not eligible. We see the same pattern also occurs across a number of the race and ethnic groups. So we've looked at this pretty heavily, and this does seem to be a real event. It happens across different groups, it happens across different subjects, and it happens across different assessments, because not only did we see this in the math, reading, and science assessment for NAEP, we also saw it in the TIMS data, we also saw it in the PIRLS, which is a international reading assessment, and in the PISA assessments, which are another international assessment. So there's a lot of strong evidence that this is a real event that's actually occurring and not an artifact of the assessments, because we're seeing it in so many different places. And it's definitely one of the major concerns. To me, this is one of the biggest takeaways from all the NAEP releases from the 2019 data, is that we're seeing this continued pattern, because this actually started back in 2017 was when we first started to see this. So yeah, there's a lot of evidence that this is real and that it should be of a major concern.
It's helpful to see it all on one slide. Thank you for doing. All right. Another question. This is about course taking. Is course taking behavior tracked? I think the paraphrase is, do we know if students took high school science in grade 8 or AP courses? How much do we know about their course taking?
It's a good question. We do ask students about their current course taking patterns and whether they had ever taken certain courses. But I really think the best place to answer those questions is the transcript studies that I mentioned earlier in my talk. We're going to be releasing those data very soon. The high school transcript studies look at transcripts back to 8th grade. So the 8th grade information is sort of included in the high school transcript study, especially something like the math, the early math courses that students take in Algebra 1, for example. They would be indicated there. So that's really the best place to sort of track course taking patterns. And then they're actually what they took, as opposed to what kids tell you they took, and they don't always remember correctly.
Okay, yes. Thank you. Next, does NAEP measure differences for students who attend different types of schools? So charter schools, public schools.
Yes, we do. The data that I just shared included private schools, but not enough to bifurcate them in the way that we would like. They are included there. We typically get more or higher response rates from the Catholic schools. So we're not able to sometimes even break out just the public versus the private. It's all in our NAEP Data Explorer. This is sort of a plug for the NAEP Data Explorer. Once again, we also have information on charter schools. You can just go in and bifurcate the data that way as well. I'm not recalling the exact findings for the charter schools, but of course the private schools, Catholic schools always score higher. Well, not of course, but it's a matter of fact.
Well,
So I just want to follow on what Peggy said. It's really important for people to remember that the only assessments in NAEP that are required for states and schools to participate are the 4th grade and 8th grade reading and math assessments. And it's never required that a private school participate. It's always an optional participation. And so when Dr. Carr says that, we don't have the numbers for the private schools to split them out, for example, among Catholic and non-Catholic private schools, what she's being nice and saying is there's just not enough private schools that we ask to participate who actually do participate. So if people want to see more information about private schools, if your kid attends private schools and you want to see more breakouts, please encourage your schools, if they're asked to participate in NAEP, to participate. The other important thing to remember is that, again, science is not required for anybody.
Right.
And so any schools that are participating in this did so voluntarily. So again, the more people participate, the stronger the results we can produce are.
I love it. It's recruitment. We present results and we do some recruitment too. This is good. And I do like a lot of the questions that have been popping up. We've got lots of questions. A lot of them are addressable through the nationsreportcard.gov that you're talking about. There's so many really great tools on there and graphs and ways to kind of check into the data. So some of these will definitely be answered by going to the nationsreportcard.gov. There is a question perhaps along the similar lines, but that you can kind of dig into. Are there any data about income-based gaps?
Well, we continue to use free and reduced price lunch as an indicator, a proxy, but it is exactly that. And the validity of that measure is getting poor as changes in how the variable is actually used in our schools emerges. So at this point, we're still using the variable because at the level that we analyze the data, it is acceptable. But we are looking at alternatives, which Lynn has been really instrumental in embarking upon, trying to get us better measures of SES. And perhaps you can share more about those activities, Lynn.
Sure. Thank you, Dr. Carr. So in our current assessments, the way we break the data out is by free and reduced price lunch eligible. And essentially that means students who are at 185% of the poverty level or below are classified as students in poverty. And then the students who are above that level are classified as students not in poverty. Of course, as Dr. Carr has mentioned, there are some validity issues around this. So the school lunch program was always meant to provide kids lunch. It was intended to put food in the stomachs of hungry children. And it's a great program. It's actually run by the U.S. Department of Agriculture. And they've expanded the program to maximize the number of kids who are getting lunches and getting fed, which is a great thing. We very much support that. However, we in the education world have been borrowing that indicator as a proxy for poverty. And because they're expanding the program to help more kids get fed, it makes it a little less effective for our uses. We are in the current testing phases of an experimental design in which we could use the basically where people live to get an estimate of what we think their income levels would be on a little bit broader scale. Instead of just being 1 and 0, we would have multiple levels, and that we hope that'll be in the future will be useful providing more information, but we're still a couple of years away on getting all the details worked out on that to make sure that it has the level of accuracy that we demand as a federal statistical agency. So yes, there is information on poverty, but it's a fairly blunt instrument. We are working to get something a little more accurate.
Always improving. There's a question about, Peggy, you mentioned scenario-based tasks, and someone asks how scenario-based tasks are graded by a computer or people. How does that all work?
Well, they're mostly hand scored. There are some discrete items, meaning, multiple choice, that the answer is one or the other. But mostly these are hand scored tasks. We have on average about 6 to 10 items per scenario-based task, depending on how long it is. So that 12th grade one that I showed earlier in the video was only 15 minutes, so that wouldn't have as many tasks in it. But they all have a multifaceted approach to the types of items that are included in the task, mostly hand scored.
Thank you. There's a couple of people have asked about Department of Defense schools. And so why we don't have Department of Defense schools for this release. So maybe we can explain.
I think the department, I have to check. I think the Department of Defense schools were included. Perhaps I didn't report out on them today. So let me hold off on verifying that and checking my notes here just a little bit. But Department of Defense schools are high scoring. They're among our most high scoring jurisdiction. We collect data both domestically and internationally, but report them out as a group. And we've been doing this for a couple of decades now. But let me see if I can dig up the findings for the Department of Defense schools. But I'd be surprised if they're not stellar, as they always are.
No one mentions if they are actually members of the Defense Department asking, but certainly I like that. So I think we only have about a minute or two left in the Q&A. If both of you would like to give some just closing remarks or anything, you're welcome to do so. And we'll move over to the next part of it.
Yeah, so I want to thank you, Laura, for kind of managing and wrangling the Q&A for us. If you have questions, of course, you can always reach out to NCES. We're happy to work with folks to help them understand the data. There have been several references to the Nation's Report Card, which is nationsreportcard.gov, which is one of the websites where you can see the results. You can also go to the Nape Data Explorer, which is another site that allows you to go in there and actually dig into the results and do breakouts, and you can create custom cross tabulations and get a lot of information that way. So as Commissioner of NCES, I'm going to officially close the statistical release portion of the National Center for Education Statistics release of the 2019 Nape Science Assessment results. And we will now hand these back over to the National Assessment Governing Board for the remainder of the program.
Well, and I thank you very much. Thank you for this presentation and for answering all the questions. Lots of interest in this. So thank you very, very much. And so now, as Commissioner Woodworth teased, we are, let's talk about what all this means for science education. So we'll hear from a current member and a former member of the National Assessment Governing Board who will respond to questions from national experts. And the board members are, you may remember her from earlier, our esteemed MC Christine Cunningham, Professor of Practice in Education and Engineering at the Pennsylvania State University, and Carrie Snyder, who is a visiting scholar at Portland State University and is a very honored member emeritus of the National Assessment Governing Board. And we will invited, well, first of all, thank you so much for being part of this conversation. Carrie's gonna pop up in a second. We invited experts in science education to ask some questions based on their, based on the science results and based on what they'd like to know about how NAEP results have meaning for policy work and advocacy work and for kids in science classrooms. So our first question is from Kimbrell Barbosa Lewis, who is the president of the National Association of Elementary School Principals.
For fourth graders, lower and middle performing students' scores decreased compared to 2015, while higher performing students experienced increases. We know that schools strive to have growth faster with students who may have a lower performance level. How do the 2019 NAEP science results speak to that? And what are the implications for science instruction in the future for these students?
So she is asking, in a very insightful question, what are the implications for science instruction for lower performing students whose scores decreased in 2019 compared to 2015?
Dr. Lewis is pointing out a very disturbing aspect of these data. The achievement gap between students who are struggling and those who are doing well is increasing. So on average, scores for all fourth grade students fell 2 points from 2015 to 2019. However, students whose scores were in the top 10% saw no change, while students whose scores were in the lowest 10% fell by 5 points. And this 5-point drop was shared by both Black and white students. To gain some insight into why that might be, I think we need to think about what may be happening in classrooms with students scoring in the lowest 10% on NAEP. What I would like to see is that these students are engaged in hands-on project-based activities, because if done well, this approach can lead to increases in math and language skills as well as science.
Now, my guess about why students' scores in the lowest percentiles are decreasing is that teachers of struggling students are being told to focus on the basics. That's reading and math. So they have little opportunity to even engage with science. And when science is taught with a basics approach, it usually means repetition of low-level skills. So kids in the highest percentiles, on the other hand, are often given more challenging hands-on activities. That increases their motivation and provides more opportunities to develop the kinds of high-level science skills that NAEP measures. So to hear some ideas about what could be done to turn things around, let's turn to Erika Shugart. She's the Executive Director of the National Science Teaching Association.
The National Science Teaching Association recently asked teachers what are the 2 biggest challenges facing science education in the next decade. Out of over 1,100 open-ended responses, lack of time for teaching science, competition with math and English language arts, and lack of qualified teachers, all at the elementary school level, were cited as major challenges.
Dr. Shugart is asking a very compelling question about the challenges facing teaching science at all elementary school levels, and your thoughts on that.
So let's take a look at these challenges. First is the need for more highly qualified teachers. I don't think we should blame teachers for what they have not received, either while earning their college degrees or on the job. Teachers need high quality education about how to integrate science with the subjects they teach. University professors and instructors, as well as district leaders, have this power to help elementary teachers learn to incorporate science as a daily activity, integrated with math, social studies, and English language arts. Students naturally use language, reading, writing, and speaking in authentic ways during science activities. Teachers can be encouraged to connect these various disciplines.
So for that second point about time spent on science, let's hear from Beth Allen. She's the president of the National Science Teaching Association.
The nation's report card shows that average fourth grade scores have declined since 2015. What are your recommendations for how to make systemic changes to incentivize more science instructional time at the elementary level?
That's a great question. So how do we incentivize more science instruction time at the elementary school level?
Well, Dr. Shugart and Dr. Allen both know that most kids won't learn science if there's no time for it in the curriculum. There's a number of studies that show that science is being crowded out of the school schedule. Today, elementary teachers spend twice as much time on reading as they do on science and social studies combined. So how can teachers be incentivized to spend more time on science? Well, that's the job of their principals and instructional coaches. It's not uncommon for elementary teachers to be told not to spend any time on science because the high stakes tests are in reading and math, not in science. Today, right now, it's important for the people who hold power in schools and districts to mandate a minimum amount of time on science every day and to provide teachers with high quality professional learning opportunities to support this policy.
Parents are also a powerful force. They can either encourage or discourage their children from pursuing STEM, initially as a personal interest and later perhaps as a career choice. So programs and resources for parents that invite them to engage in science and consider the possibilities for their children are critical, particularly in communities where parents may not have had access to high quality science education previously. But it's not just enough for us to put pressure on parents, teachers, principals, coaches, or university professors. We need to look to the state departments of education and the US Congress. Let's start with this insightful question from one of the nation's educational leaders, Eileen Parsons, a science education professor at the University of North Carolina at Chapel Hill.
I bring an equity lens situated in social historical tradition to my work. Few systemic efforts address structural concerns. Unfortunately, individual characteristics like motivation, rather than structural ones like the distribution of material and human resources for optimal learning, tacitly and explicitly dominate discourse, action, and even presentation of data. What is the breakdown by race, by educational condition, for lack of a better term, for the percentile score groupings from the 10th to the 90th percentile? And what might this mean for the interpretation of the Nape science achievement data?
This is that question that keeps coming up, right? So how does the breakdown of scores by race and or other demographics like we saw earlier affect the interpretation of the Nape science results?
There's a lot to address in Dr. Parsons' question. She's quite right that efforts to reduce achievement gaps in STEM have largely focused on ways to motivate students of colors and to provide after school or summer enrichment programs from students from poorly resourced inner city and rural schools. Although important and valuable, such efforts do not address the fundamental structural problem that public schools receive about 50% of their funding from local property taxes. Thus, schools in wealthy communities have far greater resources. There are funding disparities that we desperately need to address by reconsidering school funding models. We would expect these disparities to abate when there's equality of learning opportunity.
To sum up, the falling scores of fourth grade students should be a wake-up call for the nation. We must support more time for science in the school day, as well as professional learning opportunities for teachers about how to implement their state science standards and meet the needs of struggling students. And as a nation, we must provide additional state and federal dollars for science education and begin to address the unfair way that our schools are funded.
The real rallying call. We have a little bit of time left. And Peggy threw a question out from the first part to this part. I'm wondering if we can actually, because several people did ask questions in the Q&A about the next generation science standards. And then Peggy said, Carrie. But Christine, obviously you're welcome to as well. But I'm wondering if you have any thoughts on that question that was from earlier.
Well, I'm glad you asked. So all of the assessments in science we're looking at, 2009, 2015, 2019, are based on the 2009 framework in science. I worked on that one as well as on the NGSS. Now, keep in mind, that's 4 years before the NGSS were released, before they were even developed. So all we had to go on were documents from the 1990s and 50 state standards, and they were very, very different. So it's not surprising that there is significant differences between the assessment that's being given even today and the NGSS. However, the board also developed a different assessment called the Technology and Engineering Literacy Assessment. If you look at those questions along with the science questions, what we have is actually a fairly good match to the NGSS. So in future, we really need to rethink again what we're going to be assessing. And I think we should start thinking about using both of those combined and looking at the NGSS. But as always, NAEP tends to kind of leapfrog. We follow what kids have been learning in the country to assess it properly, but we try to take the leading edge. So how should the country be going perhaps in the future? We need to always be looking at the future and making sure that we are assessing what kids are going to be needing, not just today, but when they're finished their schooling and they're in the world and leading our country in the world.
Well, and what, several people have asked throughout the Q&A about that. Like, what do these findings mean for, the future? Like, how should we think about how this impacts, not only students' education, but students' lives, like how these should be considered as impacting the future. But I think you're kind of, you're looking at it from the assessment, but also the results. I feel like that might be the last question if you want to address that. I'm just throwing it out there because there's a little bit of time.
I'm going to take a quick shot and then invite Christine if you have something to add. So the NGSS includes technology and engineering. That's where science meets the road. That's where science is put to work to apply to what people actually need for society and for the environment. So what we're getting to now is a kind of science education that addresses the major problems of society, like clean water and sustainable environment. And actually that is what both the technology and engineering literacy assessment and science combined actually measure. So these results are extremely important in terms of how we're preparing our kids to address the needs of the world. Christine, do you want to add to that?
Yeah, I think the other piece that is present in the 2019 NAEP and will be also, I think, even more important going forward and also aligned with the NGSS is this focus on scientific practices. So as students have the factoids of the world at their fingertips, it becomes really important to think about what can they do and how can they use those data more and more. So it's a different way of learning. It's a different way of accessing information. And I think in 2019, there are some strands about scientific inquiry and higher sort of even beyond skills to interpretation of data. And I think as we look forward, it's going to be those skills that are particularly important as we equip students who are ready to enter a workforce in a world where they can use the internet to get answers to any little question that they might want to do, but then need to think about how they apply that, interpret it, or use it to change the world they live in with sort of a scientific basis.
That's great. Thank you. Thank you for rolling with the bonus question to both of you. And I just want to thank you so much to our questioners, who recorded their questions in advance, to the questioners from our online audience, and to you, Christine and Carrie, who have given us a lot to think about today. So thank you to everyone for joining us today. A recording of the event will be posted soon on nagb.gov. Have a great afternoon, and hopefully we'll see you soon. Thanks so much.